It's algebra time, and today we're going to find out where a real important formula comes from. It's called the quadratic formula, and I know a lot of you probably think that formulas just appear out of thin air and wow, they work, but not so. Now in the case of the quadratic formula, which is the fourth way that we're going to learn how to solve quadratic equations, it actually comes from what we did in lesson 10-3, which was solving quadratic functions by completing the square. Now here's what we're going to do today. We're going to take the standard form of any old basic quadratic function, which is y equals ax squared plus bx plus c. Then we're going to follow the 6 steps that we used yesterday in lesson 10-3 to complete the square. Now what's going to happen is we're going to turn that plain old standard form equation into the wonderful quadratic formula. Now before we do that, let's take a look at yesterday's notes. You notice that when we have to complete the square, we have 6 procedures we have to carry out. So look them over again. Number 1, first we have to arrange the equation so the terms with the variables are on one side of the equation and the constant is on the other side. Second, we have to divide each term on both sides of the equation by a. And you remember, a is the coefficient of x squared. 3, you have to take the coefficient of x, which is b, and divide this number by 2. Now you take this result, square it, and then add the resulting number to both sides of the equation. Now when you do this, this should create a perfect square trinomial on the one side of the equation that has the variables on it. So that brings you to step 4. You're going to factor this trinomial. And since it's a perfect square trinomial, it's going to factor into 2 identical parentheses, which means then you can write these 2 parentheses factors as a perfect square. For example, if the perfect square trinomial factored to be x plus 2 times x plus 2 equals 9, you would get to write that as x plus 2 parentheses squared equals 9. Okay, then that brings us to step 5, which is we're going to take the square root of both sides of this equation. And then finally, number 6, we're going to isolate x. We're going to get x all by itself to find out what the solution is. Okay, now obviously you had a lot of practice problems in 10-3 to practice these 6 steps and to complete the square. But it's going to be a little bit different because the practice problems that you worked on in your homework assignment had numbers in place of the a, b, and c. You actually had numerical coefficients. Today what we're going to do is we're going to derive the quadratic formula from the standard form of a quadratic equation. So let's do that right now. Okay, we're going to start with the standard form of a quadratic function, which is ax squared plus bx plus c equals y. Now, since we're going to try and find the solution to this standard form, what we're going to do first is set the y equal to 0, because remember, when we're finding solutions, we're finding x-intercepts, and all x-intercepts have a y-coordinate of 0. So I need to first take the y out and put 0 in its place. Now that I have the right side of the equation set equal to 0, I'm going to do step 1 of completing the square, which says that I have to have the variables on one side of the equation, which means the x squared and the x term have to be on the left side, and the constant, the plain old number, in this case c represents the constant, has to be on the other side of the equation. So to do that, I'm going to subtract c from both sides of the equation. Now that I have negative c, the constant, on the right side of the equation, I go ahead and do step 2 of completing the square, which says that I have to divide every term on both sides of the equation by a, which is the coefficient of x squared. So that's what I do next. Let's see what the result is. Well, dividing every term by a gives me x squared plus b over a times x, and that's going to be equal to negative c over a on the right side of the equation. All right, now step 3 is the slightly confusing one. First, I have to take half of the coefficient of x. Well, what's half of b over a? Well, it's 1/2 times b over a, or b over 2a. Then I have to square that amount. What's b over 2a squared? Well, it's going to be b squared over 4a squared. And that's what I have to add to both sides of the equation, like this. As you can see in step 3, I've taken half the coefficient of x. Now half of b over a is b over 2a, and I've squared that, which gave me b squared over 4a squared. Now that's the amount that I've added to both the left and the right side of the equation. Now you notice on the right side of the equation I put the b squared over 4a squared in front of the negative c over a. It just kind of makes it a neater looking equation if the positive fraction is written in front of the negative fraction. Okay, now you know that if we've done everything correct up to this point, that means on the left side of the equation we should have a perfect square trinomial. And if we do, that means it's going to factor into 2 identical parentheses. Let's see if we can do that. Well, our trinomial on the left side of the equation is indeed a perfect square trinomial. And as you notice, the x times x will give you the x squared, and b over 2a times b over 2a will give you the proper third term of b squared over 4a squared. All right, great. Now, you notice on the right side of the equation, I changed something. What did I do? Well, I got a common denominator because I'd really like to be able to subtract those 2 fractions, but to do so I have to have a common denominator. Okay, well, the common denominator on the right side of this equation is going to be 4a squared. So that means I'm going to have to multiply the c over a times 4a in the numerator and 4a in the denominator, so I can have my 4a squared as the common denominator. So that's why you see the right side changing to be b squared over 4a squared minus 4ac over 4a squared. Now they have a common denominator. Okay, now it's time for step 5. Now in step 5, what I'm going to have to do is I'm going to have to take the square root of both sides of the equation. Now to do that, of course, I have to take my 2 identical parentheses that are being multiplied together on the left side, the x plus b over 2a times x plus b over 2a, and write it as a perfect square, x plus b over 2a parentheses squared. Now I'm ready to take the square root of both the left and the right side of this equation. So let's do that next. Okay, we're almost there. I've taken the square root of both sides of the equation. As you can see on the left side, the square and the square root simply cancel each other out, leaving me with x plus b over 2a. On the right side, now remember, we're looking for 2 solutions to our quadratic function, so that's why I have the positive and the negative square root. So I have positive and negative square root of b squared minus 4ac in the numerator, and then I took the square root of the denominator separately, because I can, and also because it's a perfect square. The square root of 4a squared is 2a. Okay, we're almost done. If we're going to isolate that x, we just have one more thing to do. We have to subtract b over 2a from both sides. That's step 6. Let's do it and see what it looks like. Okay, we can see the result of step 6, which is isolating x by subtracting b over 2a from both sides of the equation. Now on the left side, when I subtract b over 2a, that gives me x all by itself, just what we want. Now you notice that I've subtracted b over 2a, or taken a negative b over 2a in the front part of the right side of the equation. Doesn't really matter if you put it in front or behind, so I chose to put it in the lead position in front of the plus and minus square root of b squared minus 4ac all over 2a. Now, is there anything left we can do to simplify this? Oh, there is, because what are we doing? Well, we've got 2 fractions, right? We've got negative b over 2a being added and subtracted from the square root of b squared minus 4ac over 2a. Two separate fractions, but they have a common denominator of 2a. So what does that mean? That means we can combine their numerators together and write their numerator over the common denominator of 2a, which is right over here in red. So you notice that if we completely simplify it, we have x equals negative b plus and minus the square root of b squared minus 4ac all over 2a. And that, my friends, is the quadratic formula. So the quadratic formula wasn't just something that a mathematician pulled out of the air. They took the standard form of a quadratic function, they performed the completing the square procedure, and got a really good formula that makes solving quadratic functions a lot easier for us. So that's what we're going to use in lesson 10-4. Should be fun. We'll see you next time.